Hello everyone, today we're going to be going over the August 2024 Algebra 1 Regents exam. In this video, we're going to be looking at part 2, which is 6 short response questions, each worth 2 points. A link to this test will be in the description of this video if you want to follow along at home, and in the description is also going to be a video that goes over part 3 if you want to keep on going over this test. That being said, we're going to start off with 25, which says that on the set of axes below, graph f of x is equal to x squared plus 4x plus 1. So every single time that they're going to ask us to graph something, specifically a parabola on the Regents, I'm going to plug it into my calculator first. So I'm going to go into my calculator, I'm going to press y equals, and I'm going to copy that function here. That function was x squared plus 4x plus 1, and I'm going to hit graph. And this is going to show me the shape of this parabola. So essentially, to get full points on this question, all you need to do is take this shape right here and graph it onto here. That means that number 1, you need to have the general shape down, so it needs to be a curve, and number 2, you need to make it pass through multiple points. So the most important point that they're looking for is if it passes through its vertex. So the vertex is either the dip or the lowest point of the graph, or the tip or the highest point of the graph. In this case, we don't have a highest point, we have a lowest point, we have a dip. So our vertex is going to be this point down here. To figure out the coordinates of that vertex, you're going to go second, trace, minimum, because whenever it's a dip, it's a minimum. When it asks you for your left bound, you're going to select a value or select a part of the graph that's to the left of the dip, before the dip. And for your right bound, you're selecting a point that's after your dip or to the right of your dip. And when it asks you to guess, you just place your cursor over the dip. And it's going to tell you that the vertex is -2, -3. So that's the first point that I want to plot on this graph, okay? So I'm going to go ahead, I'm going to go 1, 2, 3, so that's -3, or you would go -2, so that's -2, -3, and that's your first point. From there on out, you just need to plot a couple more points and then just draw a curved line through them. So in order to access your next points, you just click second, graph, and it gives you a table of all of the possible points of this graph. So from my vertex, I'm just going to keep on graphing. So my vertex was at x equals -2. So then I'm going to plot the point at -3. So when x is -3, the function is equal to -2. So I have 1, 2, 3, 1, 2. So this is now going to be my second point. And a fun thing, whenever you have these parabolas, they're going to be symmetrical over the vertex. So whatever point I plot here, I can just reflect it onto this side and not have to check my table for that value. Okay? So next, I'm going to do the same thing. I'm going to see that at x equals -4, my y is equal to 1. So at x equals -4, my y is 1. And then I just flip that over to this side, right? I go 2 units here, then 2 units here. It just saves you some time. Right, then I'm going to look at x equals -5, and that's going to be 6. So at -5, you're 1, 2, 3, 4, 5, 6. Okay, and that's 1, 2, 3, 1, 2, 3. So now let's see if I can fit a final point. At x equals -6, the y value is 13. This only has 10 squares, so we can't graph that. So now we have all of our points down, including our vertex. All we need to do to get full points is just to draw a straight line through not a straight line, but a curved line that connects all these points together. So we're just going to draw a line, draw 2 arrows emanating from both ends, and that's how you get full points for the graph. Now just make sure whenever you're drawing that line, don't make it connect, okay? Do not, and what I mean by that is make it a curved line that connects all the points. Don't just connect the points and have jagged edges. If you have jagged edges, you're not going to get full points, because if we look at our graph, again, do I have any jagged edges here? Do I have any sharp turns or corners? No, it's all just a smooth curved line, okay? Now, don't forget the second part of this problem. It's going to ask us to state the coordinates of the minimum. Like that, we already calculated the minimum when we found our first point. And remember that the minimum was at -2, -3. Okay, that's why I always graph this, because usually they ask you for the vertex either way. So that's going to be the minimum. Moving on to number 26, it asks if f of x is equal to 30x squared over x plus 2, determine the value of f of 1/2. So whenever you have this notation, f of x, this way of writing f of x is equal to whatever's inside of the x is what you're plugging into x. So if f of x is equal to this function, f of 1/2 is still equal to this function when you replace x with 1/2, or when you plug in 1/2 for x. So f of 1/2 really can be rewritten as 30 and we're plugging in 1/2 for x. So 30 times 1/2 squared over 1/2 plus 2. Okay, now we could just plug this into our calculator. So 30 times 1/2 squared over 1/2 plus 2. And that's going to give us 3. So we know that f of 1/2 is equal to 3. If you wanted to do the math manually, by all means, you also could have done that. That would have given you 30 times 0.25 over 2.5, which would have been 7.5 over 2.5, which would have been 3. But in other words, the takeaway is that whenever you have f of a number, the way that you solve for that is by plugging that number in for x, or replacing every single case of x with that number and just solving for it that way. I'm going to box my answer and move on. So number 27 asks us to explain why the relation shown in the table below is a function. And whenever we're talking about a function, we're looking for a graph or a table where every x input has one and only one y output. What I mean by this is every single time, every case of x or every value of x needs to turn into only one value of y. Okay? Whenever we look at functions, for example, let's look at this function, a straight line going up and down. Every single value of x here has only one value of y. If they had two values of y, then the graph would be straight like this, right? Or the graph would turn vertical and go like that, right? Because, and I'll go back to my example over here, this graph right here would not be a function because at the, let's say this is the point 1. At the point 1, when x is equal to 1, the graph is equal to 2. Let's say this is 3. Let's say this is 4. Let's say this is 5, right? So when x is equal to 1, you'll have the y output of 2, 3, 4, and 5, which makes it not a function. In this case, every single x value or input maps onto only one y output. When you plug in -1, you get 2. When you plug in 0, you get 4. When you plug in 1, you get 4. When you plug in 2, you get 5. Every single x value corresponds to only one y value, which is what makes this a function. So if you want to explain that, you can say that the table represents a function because every x value maps onto one y value. Right, and or you could say that it represents a function because every x input corresponds to only one y output. Every x value corresponds to only one y value. None of the y values repeat, none of the x values have multiple y values. Just as long as you mention that each one of these corresponds to only, each one of these x's only corresponds to one y. Now, the second part of this question asks us to complete a table with values for both x and y so that the new relationship is not a function. So all you have to do here to get full points is to do the opposite of what I just said. I just said that the only way that you can have a function is if the x input, if the x value only goes to one y value. If it goes to multiple y values, if let's say x is when x is 2, so when x is 2, y is equal to 5, and y is equal to 7, right? That would be not a function because this x input is now mapping onto two y outputs. So we can just put that in here and we'll get full points. You can do this in order to get full points from here. You just need to plug in any one of these points. So you could have written -1 in there. You could have written 0, 1, or 2 in there. You would have gotten full points as long as you paired it with a new y value. So if you put 1 and 4, that would just be repeating the table. That wouldn't give you full points. You need to take one of the x values or one of the x inputs from this table and show that it has multiple y outputs. That's all you needed to do. Moving on to number 28, it asks us to solve algebraically for x. So all we have to do here, I just like rewriting it before I do the algebra. So we have 0.05 times x minus 3 is equal to 0.35 x minus 7.5. So my first step would be to evaluate whatever's in the parentheses, but I can't because I can't evaluate x minus 3. I can't subtract from a variable, right? So my next step would be to break this out of the parentheses by distributing this 0.05. So what I mean by distribute is multiply everything on the inside by what's on the outside. So here I have 0.05 times x, which will give me 0.05 x, and then I have 0.05 times negative 3, which is negative 0.15. And this is equal to 0.35 x minus 7.5. So now what I want to do is I want to move around my variables. I want to get my x's on one side and my numbers on the other. Let's say that I want my x's here and my numbers here. How am I going to do that? Well, I'm going to have to move this x to the right. So I'm going to subtract by 0.05x on both sides. That way this term can cancel out, and I'll be left with negative 0.15 is equal to 0.30x minus 7.5. Now you have to add 7.5 on both sides. So we'll add 7.5 on both sides. Don't try to do the math in your head. Use your calculator. So let's do negative 0.15 plus 7.5. That's what I added. Yep, plus 7.5. That's going to give you 7.35. So now you're left with 7.35 is equal to 0.30x, or 0.30 times x. In order to solve for x, all I need to do is just divide both sides by 0.30 to cancel out that multiplication. 7.35 divided by 0.30 is going to give me 24.5. So x is equal to 24.5. That's going to be my answer. It's very simple. Just combine like terms and don't get confused with the math. If you write down the operation underneath your variables whenever you're adding or subtracting or moving terms, it makes it a lot easier because you could actually see what you're subtracting and if that makes sense or not. So number 29 asks us to use the quadratic formula to determine the exact roots of x squared plus 3x minus 6 is equal to 0. So if you don't know what the quadratic formula is, it gives us the roots or the zeros of a function, and it looks something like this. It's negative b plus minus radical b squared minus 4ac over 2a. Okay? And whenever you have a function, it's always going to have an a, b, and c value. The a value is going to be whatever's in front of the x squared. The b is going to be whatever's in front of the x that's not squared, and the c is going to be whatever value does not have an x attached to it. So in this case, x squared plus 3x minus 6, our a is actually going to be 1. Remember that 1 times x squared is still equal to x squared, and that there's always going to be an imaginary 1 whenever you're just left with x alone. There's always an imaginary 1 in front of it. So our a is equal to 1. Our b is going to be the number in front of the x that's not being squared, which in this case is 3. And our c isn't 6, it's actually negative 6, right? Our c is whatever's left at the end, which is going to be negative 6. So now all I need to do is plug these values into this function, or this equation right here. So negative b, if b is 3, that's going to be negative 3 plus minus radical b squared, 3 squared is 9, minus 4 times a, which is 1, times c, which is negative 6. And I'm going to divide this by 2, because 2 times 1 is 2. So now I want to just evaluate whatever's in the parentheses. 4 times 1 is going to be 4, and 4 times negative 6 is going to be negative 24. So in my parentheses, it's really going to, 4ac is going to turn out into negative 24. And now what I want, because I have the negative next to another negative, that turns into a plus sign. So I can break this negative 24 out of its parentheses, and I'm left with 9 plus 24. Okay? So now we have to evaluate 9 plus 24, and 9 plus 24 is going to be 33. So I'm left with negative 3 plus minus radical 33 over 2. Now, usually you want to simplify your radical, but radical 33 cannot break down into any perfect squares, so your answer is just going to be negative 3 plus radical 33 over 2, and negative 3 minus radical 33 over 2. Those are going to be your two exact roots. Now, notice how I didn't put this into my calculator. Whenever the Regents is asking you to use the exact roots, you're going to leave it in this form. You're not going to evaluate it because this will give you the exact form. If you were to plug this into your calculator, you will have to round your answer, and the calculator will automatically round your answer after like 8 decimal points, right? This is going to be an irrational number, meaning that you need to represent it in this form to get full points. So the takeaway is that exact is always going to be this form right here. You're going to leave it in this simplified form. This form, but simplified. Now, if the problem said round your answer to nearest 10, 100, 1,000, then that's when you would know, hey, I need to plug this into my calculator. But because they didn't tell you that, you leave your answer like this. Moving on to 30, it asks us to factor 5x cubed minus 80x completely. So when you're trying to factor something, you're trying to take away or take out as many terms from both of these parts of the function as you can. So the way that I like to go about this is to separate these two terms into what makes them up. So 5x cubed is actually equal to 5 times x cubed. And whenever something is raised to the power of 3, that's actually the same thing as saying 3 times itself, right? So 5x cubed is actually equal to 5 times x times x times x, okay? And 80x is actually equal to 80 times x. So what do these two terms have in common? What can I take away from both of these terms? Well, from these terms, I can take out 1x. They both share 1x. So out of these two terms, I can take out an x, okay? Now, is 80 divisible by 5? Yes, the answer is yes. 80 divided by 5, if you don't want to do it manually, is going to be 16. Okay, so not only can I take away 1x because they share an x, they actually share a 5, because remember that 16 times 5 is actually equal to 80. So 80x is the same thing as saying 16 times 5 times x. That would still be 80x. And now I can take away this other 5. Okay, so I'm taking away an x from both of these, and I'm taking away a 5 from both of these, which means I'm taking away 5x. This is just a fancy way of saying that I'm going to divide both of these terms by 5x, or that 5x is the greatest common factor between them. So now I'm going to take away 5x. I'm going to be left with x squared minus 16. Okay? So if you're unsure on what term to take out, I always like to break them apart into their simplest forms, right? So I broke this down into its simplest form, this down into the simplest form, and now I can actually see what I can take away. So I see the number I take away, which is 5, and I just slap it onto however many x's I take away, which in this case is 1. Okay, so now that I've factored out that 5x, I'm left with x squared minus 16. Now, if you left that as your answer, you would actually be wrong, because x squared minus 16 is a special scenario where you can factor this out even further. For the Regents, you need to understand that a squared minus b squared is the same thing as saying a plus b times a minus b. So if you have two terms, it's called the difference of two squares. So notice how x squared is a perfect square, right? That's x times x. And 16 is a perfect square because that's actually 4 times 4. So whenever you have two perfect squares that are being subtracted from one another, you can rewrite it as a plus b times a minus b. So in this case, a is going to be the first term. That represents x. And b is going to be negative 16. That represents b. So I can actually rewrite this as x plus 4 times... Oop, didn't mean to make that intersect. So you can rewrite it as x plus 4 times x minus 4. And then just close that parentheses, right? So that's just something that you need to recognize here. Whenever you have x squared minus a perfect square like 9 or 16 or 25 or 81, that is going to be a dead giveaway that there's a perfect square there, and you're going to have to split it up into x plus that number times x minus that number. So now that I've broken or I've simplified this further down into here, I just need to bring down my 5x, and this is the completely factored version of 5x cubed minus 80x. Now that's also the last question for part 2. Like I said, Part 3, or the video going over part 3, is already in the link to this description if you want to keep on going over this test at home. If you have any questions from this section, please let me know in the comments below. I'll try to address your questions as quickly as possible. If you have any material that you want me to specifically go over, again, ask me in the comments. I'll try to get back to you. I'll make a video on it. Other than that, I hope you guys learned something, and I hope you have a nice day.